So a very good morning to everybody. Welcome to the day one of the GSE security stream for the GSE Conference 2020. If you don't know me already, and I'm looking at the list of participants, most of you do, my name's Jamie Pease. I'm the chairman of the security working group. So you're very, very welcome. Just a quick intro. So we've got a lot of sessions over the next 2 weeks on the security stream. We've got I think it's 17 sessions spread out over the 2 weeks. We've got some more sessions coming up today. And don't forget, there's also lots of other sessions on the conference agenda as well. And some of that will be security content on the other stream. So do have a look out for that and join those if you can. So this session is 2AA. So you heard Mark Wilson talk yesterday about feedback. So if you can see your screens now, you'll see a QR code there. So do make sure that at the end of this session you give your feedback. I'm sure Andy and the rest of us will be very, very grateful for that. This session is being recorded, and a link will be made available to you after the conference so that you can listen to playback as well. If you've got any questions throughout this session, please do pop them in the chat, and Sue Parsons, who's assisting me throughout the conference, will read out your questions for you, and Andy's happy to take questions throughout, so Sue will periodically interrupt him. So yeah, don't forget to give your feedback. The important thing about feedback is that for question 1, the best answer to give is 5 rather than 9. That's very important to note. And then for the rest of the questions, the very best answer is 9. A copy of Andy's presentation will be made available on the conference website, and you'll be able to download that with the little elephant logo. So without further ado, it gives me great pleasure to introduce you to Andy. Andy, a very good morning to you. Andy and I used to work together at IBM, and I have a quick question for you, Andy. So in the spirit of the GSE conference, when we would, of course, normally be in the bar at Whittlebury Hall on Monday night, did you have a few wee drams last night up there in Scotland?
I did, actually.
Did you? Good man.
Yeah. Yeah, I kind of raised a virtual glass, a literal glass to everybody.
Very, very good. I had a few GNTs as well. I was watching something on Netflix, but wasn't the same as being in the bar. But anyway, Andy, it's over to you. Take it away.
Yeah, okay. Thank you. Thanks for the introduction. Good morning, everybody. It's great to see so many names. I've missed you all. God, I don't know. And here we are on Zoom again. It feels like we do so much. This time, GSE did some Zoom training for everyone, which I've done quite a lot of Zoom, but I attended and learned so much. So hence the white shirt, which is actually ironed, and tidied up my background so you can't see my, Encryption for Dummies books and all that sort of stuff, and so on. Yeah, there's my QR code, and I must admit, while Jamie was introducing me there, I thought, I probably should have tested that. So if it is feedback for me, then be really positive, yeah. And if it's for somebody else, judge as you think fit, yeah. Okay, so I've got about 40 minutes or so of this. Here's the first slide. I'm going to labour this one a little bit. You'll be sick of it by the end of the fortnight, I think, but maybe it's the first time you've seen it. So yeah, we've got a charity. There's a link on there. Please be generous. And also thanks to our sponsors, Maintegrity, as well. NHS Charities, what a fabulous charity. Okay, so moving on. That's me with the Z coming out of the ear there. I'm going to talk about data privacy passports mainly, but I'm also going to talk about it in the context of more modern security and how security is evolving. I actually work these days in hardware pre-sales tech support, which is not very close to data privacy passports, but how can I put this? I know, Jamie, you've mentioned before about your motivation for being so passionate about security, and some of that definitely applies to me in the sense that you hear so often of data breaches, and quite often you hear about it in the context of reputational attack on the company, reputational effects on the company, or the cost to the company. Obviously, I'm quite ratty about the effects on me. I'm getting quite fed up with the whole data breaches, how it affects me personally. So I do a lot with encryption. I do a lot with security, motivated from that personal agenda, I suppose. with regards to GSE, I was trying to think how many times I've presented to GSE over the years, and I really can't. But I think for maybe 25 years, I've been fairly regular in terms of presenting, some more memorable than others. And it's always good to present at the conference, so it's great to be here. So what I'm going to talk about specifically today, a little bit about zero trust and data-centric audit protection, much more about data privacy passports, which is an IBM program product. I'm going to talk about where it fits in the bigger context of that, and then extending that context, talk a little bit about confidential computing, which is a presentation in itself, which I'll be doing in February for GSE next session. And finally, just passing through homomorphic encryption. I find I get somehow attracted to this technology that's got good names like encryption and homomorphic encryption, which makes my point very nicely, which is I wish I wasn't so attracted to technology that's so difficult to say in presentations. Anyway, that's the rod for my own back. So we make a start. So here we go then. This is the usual, it always feels like semi-marketing to put something like this up. But just to fly through this lot, we're anticipating, of course, there's going to be a vast amount of data around. There already is, of course. Cloud and multi-cloud is coming, if it's not here already. The cost of a data breach is huge. I've got a number here that was plucked by somebody in quite recently. Breach level index, 72 data records lost or stolen every second. So even as we're talking, and even as I was doing the introduction here, loads of data has been stolen. Financial motivation, and of course we know that insider actions of that is very closely associated with all of this as well. But the main thing that I'm interested in professionally and personally is how little data that is breached is encrypted. This is important, of course, and it hardly goes without saying in this audience that if data is breached and encrypted, it finds itself out into the wild, but it's you still have control of the keys, and the baddies don't have control of the keys, then there's essentially nothing to see here, So why not have that number as high as possible? And it's still frustrating that year after year we still see that number is something like 4%. So that kind of is the context for where this presentation is going. It's about data protection and specifically about encryption. So zero trust. So zero trust is where we're going, I think, as a security community. So it really doesn't seem very long ago that I, as a sysprog, had access to just about everything, and obviously wouldn't abuse that, but we had access to everything because we made a very valid point at the time that we needed access to such a lot of things for operational reasons. Then came good auditing, and questions started to be asked about, have you really got access to this? And the answers were, yeah, but we'd never abuse it. And the auditors were not satisfied, quite rightly too. So we progressed from an operational assurance sort of model where, we make these promises that, and you see them still, you see them every time you sign up to a new website, don't you? Your data privacy, your data protection is very important to us. And then there's a breach, and there's an inevitable sorry. And then there's some sort of message that says, but we've got no evidence that bad people ever got hold of your data. And sometimes they say that the day after, but the data's out there forever now, isn't it? And that's very frustrating. So where the security world is moving is into technical assurance. So having said, we promise we won't touch your data, we're moving to a place where we just can't touch the data. It is completely protected. So that the people who manipulate the data, the people who analyze the data, cannot breach that data. That's where we're going for this, and we'll be certifying that to external authorities, so you can trust that statement. That feels appropriate. It feels like the right place to be going. That there are technological challenges for sure going that way. To some extent, ZOS is pretty close in many ways into that place. But of course, as we see the development of cloud and other platforms, and we see the development of Internet of Things and edge computing and so on and so on, these are different models that, of course, mainframe that is an area that mainframe is playing in. We're very, very serious about working in each of these new technological models. So we need to think about an environment that's much bigger than what we're used to in the ZOS world. I've got it down there at the bottom of the slide, confidential computing. It's an element of that zero trust and the technical assurance. It's not the only part of it. And in fact, confidential computing, as I'll explain in a few slides, has a fairly tight defined definition. And I think IBM are using that confidential computing word, but in a much broader sense for reasons that I'll try and make obvious. So getting on to the more specifics about data privacy passports, the IBM program product that's been around for about 6 months or so. From a data privacy issue, here's a problem statement. Of course, there are more, but here's one I want to focus on. And that is that once you share data legitimately inside your organization or with partners or with customers, the protection of that data that you shared actually falls to the new custodian or the person who you made that copy for. And once you've done that, that person's free to operate and can copy and share and post or be breached, of course. And that's out of the control of the data owner. And that doesn't sound sensible. It doesn't sound like what you'd want. But depending on the legislation that the data is operating under, that might not actually be legal. You know, I need to say, you know, GDPR, I need to say PCI DSS. The states have got new legislation and so on and so on. You know, we're very familiar with this. Yet it's sort of an elephant in the room that we know about data proliferation. We know that our crown jewels are taken off the mainframe, for example, or indeed put onto the mainframe from other sources. And once they're copied, that the protection may be different from what the data owner thinks the protection is and should be. So I hope that resonates with you. I hope that resonates as a problem statement. So we'll build on that. Here's another statement just to uncover a little bit about what's happening with that trust. And so you may have some data that's off platform and you bring it onto the mainframe for some analysis before moving it off. You may have traditional Z data that you're moving off into a data lake for analysis or whatever it might be. As you pass that data around, of course, it might start off well encrypted, but typically it'll be unencrypted for passing the data down a secure network or otherwise, of course. And then it may well be encrypted at the other end, and it may well have some appropriate security around at the other end. People will come and go and do the processing of that. They'll come and go in the project itself, for example, or if you've shared it with a business partner, people will come and go from that business partner. But you don't really know, do you? So there's trust going on there. There's a very clear message that you should keep appropriate data for only as long as it's necessary. So you're trusting that the data gets purged. You don't really know. And of course, you're trusting that people that value your data as much as you do. And it may well be that perhaps you're sharing this within a small and tight community of people that you know, and you're confident about this. You know, that's the old trust statement, isn't it? But are your auditors? So your auditors may well not be happy with your trust-based arguments that everything is safe. So IBM looked at that as a problem statement and came up with this program product called IBM Data Privacy Passports, which I often refer to as a privacy hub, which feels a little bit more appropriate to my mind, as to what it's actually doing, which is a hub that's looking after the privacy of identified sensitive data. So for this to address that problem statement, that privacy hub, it needs to manage the data privacy by policy. So do you remember what we did with ZOS data set encryption, where there's policy-driven things? You make some statement about what security looks like, or in that case, what encryption looks like. And then the people who are maintaining those policies don't have access to the data. Of course, they're not particularly close to the data either. There needs to be something like that, analogous to that in this. So that interprets who is entitled to which of the data is sensitive, when, by which I imply that there needs to be a real-time element of this. It must itself protect the data, so protecting that sensitive data in a way that's congruent with...
We work aside.
Oh, excuse me, Francis. Yeah, protect the data in a way that's congruent with modern thinking of that. And essentially what that means is that the protection of the data is in the data itself, or it's wrapped around by the data, such that if the data gets free somewhere in the web, it is still protected. So good quality sensitive data protection has to be in this. There needs to be key management in there as well, I think for obvious reasons. But the key management, it needs to be quite granular for reasons that I'll go into later. But a granular key management system allows you to do propose solutions that are not just project-wide or population-wide, but potentially, small parts of the population of the projects wide and different within parts of that project. The Privacy Hub needs to validate a request. So you get a request in to serve some sensitive data. It needs to validate that by interacting with LDAP or some other external security manager. Do some decryption if necessary, or unmasking if that's the way the data has been protected, and then serve the data according to that policy. It has to work cross-platform because we're way out of the days of presenting niche solutions, and actually has to work cross-enterprise, by which I mean we need to have a method of sharing data with multiple partners out in the world where we don't necessarily know what we do, but we need to keep the sensitive data protected, so cross-enterprise. And when I say it has to work with existing and emerging technologies, I essentially mean it's cloud ready. So it needs to work with all the data we've already got, and it needs to be able to work with wherever we're putting the data out in the cloud, whatever that might look like. So Data Privacy Passports does that. I'll assert that's the case. It's a developing product. We need to encrypt the keys inside that Privacy Hub because, again, we're quite conscious that breaches are happening such a lot, and we need to make sure that things like keys are not exposed with the data. Those policies can be updated by administrators, but only through a very, very tight API. So those administrators don't have access to, well, almost anything, essentially. The sensitive data needs to be protected. Now, as a project or as a partner, you'll be asked to process data. Some of that data that you're processing may be in clear, some of it may be obfuscated, and some of it may actually be encrypted, but you're entitled to have a decrypted copy of that. So it needs to be very variable in terms of the audience that you're serving, while at the same time offering this protection. I've mentioned LDAP and external security managing as well, of course. The policies need to be easily modified in real time. So what I mean by that is if you have a trusted partner, you have a partner that you're not exactly trusting, and that partner goes off shift, the project comes to the end, or the business partner is no longer a project partner or business partner of yours, you need to be able to shut down data very quickly and be able to prove that. So all of this needs to be, accesses need to be logged, access requests need to be logged, and so on and so on. So good logging for your audit and your compliance authorities. And I'm going to ask the question, if your organization is copying data, a subset of your data for a particular project, and then copies another subset for a different project, and so on and so on, you've got an enormous number of copies of project data out there, and you're losing touch with it, I think. I want to ask the question, why not just have one copy of that data and manage the access to that copy of that data, and be very confident about how you're managing that? Key management is where I'm going with that one. Okay, so here's perhaps the only pseudo-technical diagram I've got in this presentation. And it's just a schematic of what we're doing with this sort of thing. So we have source data on the left. And I wonder if you've noticed that I've not particularly talked about mainframes since the beginning of this presentation. We're very proud of the qualities of mainframe, of course, and that underlines what we're doing. But we know that the data lives pretty much anywhere. That source data on the left of that page of this presentation. I've seen this work with Postgres. I've seen it work with Amazon Web Service. I've seen it work with DB2 data, and so on and so on. That source data is non-prescriptive. I've not just said that it has to be on Z. I've not just said that it has to be Z friendly. We need to be able to get a way of accessing that data to do the protection. And we can do that. So just specifically at the moment, again, I say it's a fast developing product. JDBC sources and data that we can access through REST APIs are up for analysis and protection by this. That population of what kind of data the source data has to be for this solution is expanding very rapidly. So keep watching this space. So we take this source data, we pass it through Data Privacy Passports, through that Privacy Hub. In a sense, you can think about this as an extract, translate, and load exercise. The Privacy Hub, the Data Privacy Passports there in the middle, it has logic within it, has key management within it, policies, and it will interface to your external identity manager, out of which comes a protected table. So your sensitive data has been identified, and protected in an appropriate way for that data copy. Now, down there at the bottom, we've got some of the personas who are interested in accessing some of this data. And some of that data that they will be accessing will be confidential and sensitive and protected, and some will be in the clear. And we're not terribly interested how they access data that we've decided is in the clear. So for performance reasons, they could access that directly onto the data copy, just go and get it, fine. But for all the other data, the sensitive data that we are protecting, that access needs to go via the data privacy passports. And that action is the identifying who you are, the validating who you are, decrypting or unprotecting and serving that data for the purposes that you're entitled to and nothing else. So I did talk about Z briefly in that previous slide. The Privacy Hub runs on Z, and it runs on Z because of the immense crypto capability that is on Z, and not just the encryption, decryption speed of it, but all of that ecosystem around the Z that makes sure that we know the quality of the security that's going on here, the quality of the encryption, who people are, and so on and so on. That's an appropriate place to put that Privacy Hub. But where the data is, don't really care, actually. Well, to some extent, technologically, we do at the moment, but it's expanding, as I say. So we need a Z server, a modern Z server on here. We need to be able to run a secure service container, LPAR. So you can see that we're heading towards a Linux sort of installation area with this one. On that secure service container, we run a product called HyperProtect Virtual Server. So there's a HyperProtect suite of which virtual servers is one. And these are ways that IBM are serving data in a cloud environment. So in that suite will be things like bring your own keys to the cloud, database as a server on the cloud that's secure. The HyperProtect thing basically says it's fully locked down and certified. Within that HyperProtect virtual server, that's where we load and run the data privacy passports, privacy hub, if you like. And that's essentially it. You'll already have networking. Hopefully you'll have IFLs if you're on Z15 to be able to enable this secure service container to run. If it's a Linux 1.3, then obviously you've already got a massive Linux capability. And you need some dedicated memory and some dedicated storage for the product. Just a quick picture here. It does kind of state the obvious, but there are some terms in here. We talk about protected data when we're talking about encrypted data on data privacy passports. That works how you'd expect. It's symmetric keys, AES-256, and so on and so on. Yeah. The other part of this is what we call enforced data in data privacy passports language, and that is irreversible. So you're essentially masking in some way. And the in some way is expanding rapidly, you know, whether you need all 9s or you need all A's or percentage signs or whatever it might be. And typically it will preserve the format of that, the size of that data, you know. So if you require 16 digits, for example, the obfuscation will produce 16 ways of masking it. You can do a mixture of both. So you can mask the data and then encrypt it, or the other way around. Because do you remember I said you might have a single source of your data that includes some sensitive data, but you've got a lot of different populations who will have access validly or invalidly to some of that data. You'll want to serve data in different ways, even though it's all the same data. So some people will want data in the clear, but it has been encrypted. Some people will want data that is encrypted, but actually they need it in a particular format, a particular obfuscated format. So the mask needs to fit, as I was saying. So the data privacy passports will allow you to do that mix and match. I want to start introducing another phrase here, trusted data objects. And that is about the encryption of this data. Do you remember I talked about zero trust and the DCAP format, where the data itself holds the protection of the data itself, and it runs with the data wherever you've copied it. The data protection is fully bound to the data itself. Well, we use a trusted data object schema to describe that. Essentially, it's encrypted, and then it's wrapped around with metadata that talks about who the owner is, what sort of data this is, what the field name is, for example, what sort of protection it's got. You know, it's going to be encrypted at this point. So that trusted data object, I'll show you an image of that later on in this presentation. That TDO is part of what that encrypted data looks like. And of course, that comes with, you know, as DBAs, we understand that comes with some significant implications, more so than the masked implications. Let's get a little bit lighter. I've got 3 or 4 pages here of some use cases, so I'll just whiz through these, and I've kind of touched on them already a little bit. So one of the problems is that you share data with a business unit within your organization, potentially, not necessarily. And that project comes to an end 6 months on. The project is disbanded, the project's complete, and those people should no longer have access to the data, to the sensitive data. Okay, using the key management of data privacy passports, you just break the key, or you break who is allowed to access those keys, those specific keys for that project, remember, and you can show that you have broken access to that data. It's you know, it's designed to be simple like that and very, very auditable. The next one is, I talked about data proliferation. Of course, that's very difficult to manage, not only difficult to say, in terms of copying it, making sure who's got access to it, and so on and so on. The example here is that you've shared data with a data scientist. You shared the same data with the data scientist, with the customers themselves via a web portal, with the data regulator, and so on and so on. But you've only got one single source of this data, you know, and so that's one source of the data that you are managing, that you are backing up, that you're making sure is continuously available, and so on and so on. Data privacy passports pushes you firmly into that model, and it helps you with the data proliferation issue. Multiple roles. So it was brought to my attention that call agents at call centers, they obviously handle many different types of calls and potentially for many different types of projects, each of which will have different data secrecy rules around this. It's quite difficult conventionally to allow the call agent to swap roles dynamically, but that can be done with data privacy passports. So using the interface that I showed you earlier and the policies, that agent will take a call on one subject, finish that call, and finish their ability to access a particular view of sensitive data. Take the next call, and it'll be in a different view of that data. That can be managed and handled within the policies of data privacy passports. And finally, this one's a new one on me, but it was pointed out that if the data gets out, you know, like your data that's encrypted, but nonetheless it's out, and you find it on the dark web, or you find it on GitHub, or wherever it might be, because of that metadata that I described, you can trace back where it came from. You can trace back where the last legitimate copy owner, as it were, was. And that gives you a clue as potentially where the breach started happening. So the metadata itself can be very useful for other reasons as well. So this data privacy passports, it's offering, you know, ostensibly it comes in and talks about protecting your sensitive data, but you start seeing that it has a context within a complex system, such as we understand and we manage anyway in our Z lives. Okay, so some quick examples of what it actually, you know, how it serves the data here. I'll not spend much time on here, but here's the familiar data personas that we're familiar with. So data owner should be able to see everything by definition because they own the data. The DBA there with a regulatory hard hat. Every DBA should be wearing a hard hat, I reckon, even at home. There's a wag of the finger. Data consumers, that's most people who are accessing this data. This is the people who are doing project analysis, people who are doing marketing, you know, and so on and so on, lots of those people. And then unknown individuals, hackers, people with hoodies, you know, you just wouldn't trust them anyway. We need to be able to handle each of these people, and they're very distinctive requirements for what they need from the data. Here's a picture of data is protected, so it's encrypted, and what a data owner would see having done a query. It's actually from a Postgres database, this one. It's a screenshot from a live demo that I can run if anyone's interested in seeing this. As a data owner, you would expect that data owner to be able to see all of that data in clear, and such it is down there at the bottom. A data administrator needs to be able to do things with the database, of course, you know, run utilities and so on, some of which are very sensitive to the format of that data, but of course mustn't be able to see the actual data. And here we have an example of data. It looks obfuscated, it is obfuscated, but it's probably built on data that's also partially encrypted. So we've got an example here of encryption and obfuscation working. The data consumers, okay, so this particular data consumer in this particular project is allowed to see gender and age and province, I suppose, but nothing else. Oh, some of the data is completely obfuscated with X's. Some of it gives you the impression that you have preserved what sort of data it is, you know, so SIN there and phone, obviously numeric, mailing address obviously has an @ sign in it and so on. Quick picture here, if you were that unknown hacker getting in, what you would be served, as you'd expect, nothing. But now I want to show you the trusted data object. So this is just a part of it, but we've essentially said that the fields in this database that are characterized by the original CIF number, whatever that is, and the gender needs to be encrypted. And this is the metadata that you see that is in that you could see using a suitable print utility, for example, that is on that database. And that's the metadata. So there's an indicator of which key is being used there, what sort of data it is. The ciphertext is in there. You've got the row name in there, and so on and so on. And that's all you can see. So essentially it is ciphertext, and you can't do very much. You can, however, perform referential integrity actions on this if you are doing database joins, for example, and both databases are protected in this way. Unfortunately, I can't go into that in any greater depth because that's kind of the limit of my understanding of that, but rest assured it is designed to be able to do that. Okay, so that's essentially the end of my data privacy passports part of it. The next quarter of an hour or so, what I've got is something much more about the context of what data privacy passports is sitting in and where we're going with this. I hope you're all familiar with the pyramid of encryption.
We have got a couple of questions, Andy.
Okay, so we're kind of at a natural break, so that sounds like a good time to take them soon. Yeah.
Okay, if you go back to your last slide, if you can, please.
Oh.
Okay, does TDO keep track of length, format, and other attributes of the input data? And also, which all encryption logarithms are supported?
Okay, so the easy one first, 256A, AS256 is the encryption method that's in use. It's designed that will move. So as you know, as things progress, as quantum comes along, for example, that we start understanding that we need to be quantum resistant with this. Okay, so that's the quick answer for the first part. Now, the second part of it is you're looking at the actual data that's in the database here, or the actual protected data. And you can see that you no longer have what might have been, I don't know, let's guess 25 characters of data here is now considerably more. What's held in the database is that much, and that much expansion as well. So, sorry. So you are changing what's on there. In a database sense, it is keeping track of what the decode looks like and what that decode needs to look like. So processing can happen on it. However, for some accesses of this, the schemas will have to change if you are touching data that has been protected using this sort of encryption.
Okay, and is there any high availability solution for DPP, like supporting GDPS, PPRC, XRC?
So that's a question that has kind of multiple layers, as it were. You know, so Z to Z protection, of course. Linux to Linux protection, of course. You remember the next layer I could talk about would be the secure service containers, from that copy to that copy, of course. So we're getting more and more granular here. If you get down into the data privacy passports, there's very little in there. There's actually policies, things like what databases do I know about and where are they, and so on and so on. But there's very little in the data privacy passports. Essentially, that's an export and import. So to another copy that you would fail over onto as you require. So as always, these things are very, very nuanced. And the first question is, what are you protecting against? You know, is it full service outage? Is it fail over to the other side of the world? Some things are possible. Many things are possible. Some things are still developing. And it depends a lot on what the functional requirements of your project are, how you would implement data protection, data privacy passports to satisfy those functional requirements.
Okay, that's it, I think, for the moment.
Okay, thank you. Good questions. Okay, so the pyramid. One thing I wanted to make a point of was that you can, of course, encrypt and encrypt and encrypt. You know, it's not just one encryption and then you can't encrypt again. It's not that one encryption fits everything. Again, rather like the last conversation, what are you trying to protect against, and which is the most appropriate encryption or protection? Down there, full disk encryption. So full disk encryption of DS8 keys, for example, is down there. And you can make, you know, strong merits for doing it, and you can make a strong case for what it doesn't protect. Next one up, we could talk about ZOS dataset encryption. I hope you're familiar with now. Of course, that protects a lot in the ZOS world, and there's plenty of data out there that it doesn't protect. So what are you going to do about that one? Database encryption and app level encryption. Okay, so that requires more effort, but potentially is more customized to what you might necessarily want to do. And in a sense, data privacy passports fits in those upper echelons of the pyramid. I wanted to bring attention back to that before I start talking about this new thing. So confidential computing, I'll just read out. I know this is a slightly busy slide, and apologies for that, and the next couple of slides as well. There is a confidential computing consortium. There's another phrase that I have to say pretty slowly. Set up relatively recently, and it was because, well, it's set up by hardware manufacturers, essentially. Interestingly, I'm not quite sure that that's necessarily appropriate. Set up relatively recently to start talking about the protection of data in use. So if you remember the previous slide, we made the case for where is the encryption and why. That will be at rest, that will be at flight, but in only some specific circumstances will it be actually in use. In ZOS terms, it may be data protection encryption within DB2, or you might have applied something even higher with Guardian data encryption, or something even higher with something local that you've written yourselves. But the protecting applications data in use is, well, as there's a quote just below, I put that, and I lifted that from the Confidential Computing Consortium. They say, the ability to protect data and code while it is in use is limited in conventional computing infrastructure. That's not really true in the ZOS world, but of course we're talking about a much bigger world now of data in which the mainframe is part of. They're talking about hardware protection. I want to make the point that it should be much wider than that, and it can be wider. In the Z space, we have access to an awful lot of the stack from the chip right up to the actual application, including operating systems. Even if we don't own Linux, then we have some ability to influence some parts of Linux, as you'll see. So there are strength in depth reasons for looking at this as a bigger issue than solving it within hardware. And those are my bullet points on the left there. But the picture on the right is the Confidential Computing Consortium's attempt to pictorialize, probably with a Z, just what this picture looks like, you know. So the solid blue lines there are what they definitely think is definitely part of confidential computing. The dotted lines are what they think it might actually be as well. And I agree with them. A lot of those dotted lines, things like proper encryption, things like sharing data and computing with other parties, that's part of this as well. Okay, so moving on. One thing that comes out of the Confidential Computing Consortium is the words trusted execution environment, and other words as well, like enclaves and secure execution and so on. A trusted execution environment is a place that is guaranteed to securely protect code and data, confidentiality, integrity, and isolation, you know, all those qualities of Z that we know about already. And I hope you can see that data privacy passports fits in with an idea of that. You know, it's protecting the code and the data. The data protection travels with the data itself, and so on and so on. I've got a couple of things to talk about. On this slide, I'm going to talk mostly about software protection, software trusted execution environments. And on the next page, I'm going to talk about hardware, which is IBM's secure execution for Linux. And that was new with Z15. So keep on the software part of it. Just to fly the flag a little bit for IBM Z, the Confidential Computing Consortium started talking about developing things last year. And there's quite a bit coming to the market now, particularly as sort of try it and see type products. But I want to make the point that IBM's had confidential computing capability for about 4 years now. So if you remember things like Z-Aware, which was a protected LPAR that essentially looked after your systems running and flagged out what was different so that you could potentially fix it. blockchain ran on a confidential computing enclave, and so on and so on. Now, these products, oh, there was a GDPS appliance as well, of course. These products have, they're still there to some extent, but the idea of it has become much more cloud ready. So the idea of that confidential computing enclave, for example, a trusted execution environment, we understand that's got a lot of value in a cloud environment. And so the development of these things has become a lot less niche and a lot more mainstream. Our software solutions rely on firmware and hardware as well, because we've got access to the whole stack, so we can make such a good, tight offering for you. The machine, for example, is already EAL5 certified, so it's pretty high. I think that might be the highest level of hardware certification. So it makes sense to take advantage of all of that good stuff that we've already got. So I mentioned also about Cloud HyperProtect services earlier, of which HyperProtect Virtual Server is one. There are other products in there, so they are cloud ready. You bring them to bear on the data issue that you've got in your hybrid cloud. And that's the HyperProtect services. So I'm not going to talk any more about that, but it's going to become much more important, I think, in the future, in terms of if you want to have this data protection solution, then why not start thinking about having Linux on site to run Cloud HyperProtect in order to do that protection, even if the data is not necessarily what you would call Linux data, but it's there as a service to protect your environment. So we'll see more of that. We're seeing a lot of people, new customers, new to Zed, I might say, they are in the digital asset custody services and cryptocurrency environments, startups, people that are looking after kind of like blockchain and Bitcoin wallets, but have to have very high availability and serve that data. All those qualities of Zed built upon these sorts of trusted execution environments that we've got. I just briefly want to talk about the hardware trusted execution environment that we've got on Z15 now. It's new. And it plays into this area. It's an adjunct to what I've just said about the software version of this. It worked with that as well. But for the environment where you're going to bring up a Linux and then potentially other Linuxes and so on, how do you know that the Linuxes that you're bringing up are completely secure? They're completely what you expected. They've not been tampered with in any way. Very cleverly, I think, we use something called the hardware chain of trust, which again is a confidential computing consortium buzzword, phrase. That hardware chain of trust is done in Zed by embedding part of the asymmetric key, the private key, in the chip itself. So I've put there tamper resistant. That's in Zed terms. You know what I mean by tamper resistant is basically you'd have to break into the machine room and into the machine and hot swap a CPU to take out that one and put one in identical, but with your own private key. It's tamper resistant on steroids. Of course, it uses HSM protection. So our Crypto Express, with the FIPS 140 level 2 thing, that's the world's best. It uses that as well. It proves in hardware that the trusted execution environment is absolutely certified and guaranteed. If any part of that verification fails, then the Linux won't come up. So you can be sure that you've got a secure execution Linux environment. And some scenarios for this. Secure multi-tenant hosting, so has been shown thousands of protected isolated tenants on a single Zed cloud server, so a hybrid cloud. Industry compliance, so you can absolutely guarantee to compliance authorities that you're protecting that data. And secure blockchain, so this can be a differentiator for why you would run blockchain, which can run on many platforms. Why would you run it on Zed? Well, for the qualities of Zed reasons that I've just outlined. Okay, all right, just slightly pause for breath. Again, just a slight change of direction here, but within the context. I want to talk about fully homomorphic encryption, not least because I really like the words. What is it? Well, it enables the processing of data without giving access to it, by which I mean you take some encrypted data, typically you would unencrypt it, do some data processing, and then re-encrypt it again, probably. This is a method by which you can process the data with no decryption step involved at all. And it resolves a paradox. So this is a zero trust paradox. This is a decap paradox. The need to know versus the need to share. So you need to share some data for somebody else to do some processing on it, but they absolutely cannot have access to the data itself. Homomorphic encryption is part of that. It's quantum resistant, by which I mean the algorithms they cannot be broken any better by running on a quantum computer than they can on any, is it a Van Neumann type architecture such as Z and many traditional sorts. So it's future ready in that sense. There's a timeline there I'm not going to go into very much, but IBM invented this method of encryption in 2009 based on questions that came out when RSA was first around, which is a couple of decades ago now. When RSA started talking about how to protect data, they also said, wouldn't it be good if you could do this sort of thing? And it retained just like a mathematical interest until 2009, when the ability to do this in code became apparent. Over the next couple of years, it developed very, very slowly. And now it's in an early adoption phase. So essentially, we invite you to come and play with fully homomorphic encryption and see what it looks like. Here's just a pictorial about what our current methodology for processing encrypted data looks like. I already talked about what it looks like. You know, traditionally we decrypt, we do some work, we encrypt. In a new fully homomorphic encryption environment, your business logic runs on encrypted data. What I want to say is it's not bolt on. You need to change the business logic of this and how it works. So it's not just going to happen quickly, even if the technology was high performance already, which it isn't. When it was first demonstrated, it was 100,000 times slower using this method of processing than traditional, even at the time of a few years ago. What's being demonstrated at the moment is now only 50 times slower and only uses 20 times as much memory, but it's evolving rapidly. The sort of architecture that works very, very well for this sort of processing would be very large and very fast memory, fast chips, very fast crypto, very large cache. You can see why I'm interested in this one specifically and professionally. We've got another one of those basic security questions again. How much security do you need? You know, if you don't need a lot of security, then protecting it and processing it in this way can amount to only a few kilobytes of extra data as you balloon the data to protect it, right up to an extra 10 megabytes for Hello World. So you can see there's some work involved in this one. I've got a line here. Even after years of working in encryption, I find it difficult to conceptualize encryption. But I was told to think about hiding your data, which is in clear, hiding your data, which you can think of as in clear, in a field that's enormous, and you split it out and you obfuscate it and you change things. How big is the field? Well, the field in this case is x to the power of y, where x is a 600-bit number, which is pretty fast, to the power of y, and y is over 10,000. So you can see it's a vast space. And we're going to need some pretty clever computing to do this in production in the years ahead. But it's available now to test. You can download this from GitHub. It comes with instructions. It comes with an unzip, as it were. Try it and see. And we would really like people to try it and see and let us know, firstly, what they think about it, and even more importantly, how do they think they could use it in production? How would you go about it? Here's a slide I've got. What would you do if you could truly encrypt everything and not have to decrypt it? Here's one that's close to everybody's hearts, I think. Multiple biological companies, or development pharmaceutical companies, I should say, around the world, operating under different regimes, but collaborating on data, and they really need to get something out quick, like a vaccine, but they really don't need to be able to see secret data that's in there, confidential data that's in there. And you need to be sure of that this is that sort of, one day will be that sort of application. Fraud detection and loan analysis, so that's bank-to-bank collaboration, where in no way are they going to share with each other the details of what it is that they're sharing, but we need to do some collaborative processing on that. What about search tools? You know, you type into Google some embarrassing health ailment, just because you're interested, just for academic reasons. Because, you know, the search argument, the search engine knows who you are, and it knows why you're asking, and it'll remember that sort of thing. Why not be able to ask a question where the thing that provides the answer to you has no idea what question you've just asked, but it provides you the answer, and only you see that answer in clear. Same with maps. If I say I want to go into, I live near Edinburgh, I want to go into Edinburgh to go to my office, can you show me what the best route is? I get suggestions even now of where en route coffee shops are. Where should I park? Where did I park my car? All of that is sharing data just because I asked a question. They haven't got it yet. They shouldn't have access to that data. Yeah, I've got one, machine learning, of course. That involves modeling data and trying to produce some information out of that data. But you wouldn't necessarily want to share that revealed data with the company that you're using to help you model that data, because it's your own intellectual property, apart from everything else that I mentioned. So there's plenty of stuff, plenty of reasons that we feel that fully homomorphic encryption is going to be really important. But watch this space, I think I have to say. I think it's very exciting. It fits absolutely within that trusted execution environment. It doesn't necessarily have to be in one of those things, but it fits within the concept of that. It fits within the environment of protecting the data itself and not decrypting it and running the risk of that data then being released out into the wild. Obviously, it's a zero trust thing. I think that's it for my presentation. I've got an eye on the clock, and I think we've got about 6 or 7 minutes, definitely for questions or for just a chat about what you've seen, really. While we're thinking about that, I'm just trying to go forward. There's the QR code again. This is session 2A. Lots of questions to ask on that, or rather lots of questions to answer. And I will come back to this slide again in a second, but I did just want to flash up this one about the charity and the charity link. So bear that in mind and do support us. Okay, so that's it.
Thank you very much, Andy. Does anybody have any questions?
I have a need for tea.
Done a great job, thank you.
That's the problem with Zoom sessions, you know. I don't half drink an awful lot of tea these days.
Yep.
Hi, it's Kira. It's not so much a question as just a little comment. A number of sessions have had problems with the QR code for feedback. So if you go back into the agenda, there's a link at the bottom of the session for giving feedback, and it fills in the session ID for you.
Great, yeah, thank you, Kira. I did hear a couple of other people had had issues with it, so thank you for that. Any other questions for Andy?
Hi, Andy. Good morning. Sumit here.
Hello, Sumit.
Yeah. What would be the performance impact of using this passport? I mean, if we, let's say, for an example, if we choose a data to encrypt by AES 256, what would be the performance consequences if we are storing a clear data in a table versus protected data in another table, and we try to access it with a policy with a user having access to clear data? So if we just have to compare the two differences of accessing data from these two tables, so how much overhead can we expect?
Okay, so I'm going to answer that in 2 parts. And the very easy and very quick part of this is running on Z15 technology. The encryption and decryption part of this is, let me say, relatively negligible because of the speed of the crypto capabilities of the Z. So, plucking numbers from the top of my head, in the ZOS world, when we went from Z13 to Z14, we said that implementing ZOS dataset encryption added 10, if you were trying to do ZOS dataset encryption on a Z13, you'd have a 10% overhead of doing encryption decryption in a ZOS dataset encryption world, compared to Z14. Going to Z15, that 4%, so that 10% went down to 4% on the Z14 and went down to 1 or 2% on the Z15. It's the decryption encryption overhead is relatively negligible. So the second part of this is implementing data privacy passports in production will need some very careful architecting. You'll need to look at data access paths, how the data is served down networks, so fast networks, properly encrypted. So not just an availability of network attachments in order to get that permission and the data to be served back, but also the quality of that network has to be carefully thought about. This is selective encryption, so in a sense it's not pervasive encryption, but it's selective in the sense that the more that you want to protect with data privacy passports, the more the overhead inevitably will be in terms of interpreting the question, doing the LDAP sort of validation about whether you can have that data or not and in what sense, and then processing that data and serving that data is inevitably an overhead. It's reducing rapidly, very, very rapidly, and is production ready. But for sure, you would want to do a lot of testing on the data and how it's served and who the population are and where the population is and so on before you put that into production. It's a very good question, and it's one of those multifaceted. You need to be very careful with this one, at least, you know, at least in all the very obvious normal computing best practice professionalism sorts of senses. All of those things apply. Okay, Sumit.
Thank you so much. Just want to add one more question to it, if I may.
Yeah, sure.
What all data can be protected? I mean, just at the DB2 level? Can it be at file level? Can it be like vSAM, flat files, or data at cakes level? I mean, yeah, are there any restrictions?
All of what you just said, yes, for sure. Getting broader, well, actually, I do have to point out that this isn't a Z data solution. This is a data solution. So ultimately, we are working towards protecting data and serving data, no matter what that source of data is or where it is. Where we are at the moment, to expand on your question, data that you can get hold of with JDBC drivers, all of that for sure, yes. So that includes, you know, vSAM with the data mover. And as well as the JDBC drivers, data that you can get hold of by using a RESTful API query, which itself broadens the scope of the data that you can access and protect with this very, very much. That's not yet the state of every data everywhere, but you know, we're working as rapidly as we can on that. So the long-term answer to your question is, we expect that that your question will become irrelevant because it's all data. How long that might take, who knows? But we think we've addressed a very large chunk of that population already. So try it.
Thank you so much for the answers and sessions.
Thanks for the good questions. Thanks, Sumit.
Yeah, great question. Thank you. Okay, so we're almost at the top of the hour. Thank you so much, Andy, for taking us through your presentation. It's I kind of like I agree with what you say right at the beginning about companies, you know, who have breaches and stuff saying, I'm sorry, and it's like there seems to be, you know, like the repeat offenders and stuff, and I think that they would definitely benefit from these technologies. a lot to be you know, lessons there for them, I feel. But yeah, so thank you so much for that. Talking of Andy, so we were, before everybody joined, we were talking about the next GSE security working group, which we've already penciled in for the 4th of February 2021. I know it seems like a lifetime away, but it will be here very, very quickly, trust me. So we've already got that session on the GSE UK region website, and Andy has actually offered to come and do a session at our working group meeting on confidential computing, I think is your text. Yep. So we'll look forward to that. Don't forget to give feedback. So this is session 2AA, as Kira mentioned. If you are having problems with the QR code, you can go to the agenda and click on Andy's session, and then if you scroll through the synopsis, etc., right down the bottom, you will actually see the link to give feedback. And it's really important that you do that, because obviously it's beneficial for the presenter, and it goes towards best speaker, best user speaker, best vendor speaker awards, and also it helps us as a committee for the conference to improve for next year. So your feedback really is looked at, and we review it when we get together in December to do the kind of post review of the conference. So that's really important. So thank you for that. So right now we have, it's just gone 11 o'clock. So we have a 30-minute break. The next security session will be at midday. So it's GMT, by the way. So if you're calling in from mainland Europe, that's going to be 1 o'clock. If you're calling from East Coast of America, it's going to be 7 o'clock in the morning. So do join us for that. And that's going to be with Rob Van Hoberg, and he's going to be doing a Z-Secure update. But there are other sessions on the conference agenda scheduled at 10:30 GMT. So do join those if any of those are of interest to you. But thank you everybody for joining. I hope that the Zoom session seemed as seamless. as I've experienced. It seems to be holding up very, very well for us at least. So thank you for joining, and thank you, Andy, once again.
You're very welcome. Thanks very much.
Okay,
Everybody.
see you soon, everybody.
Cheerio.
Bye.